Right now, I think I have about 20 or so good queen-right colonies that I have. It's probably slightly under 1,000 ants for each. When I first got into ants, like this was what I was doing on the weekends. Like I was going out into the forest searching for this one species of ant. It was actually a trap jaw, which is the one that uses its jaws to, it bites the ground basically and propels itself and shoots itself up into the air. I mean, you have to have a personal interest in it because literally it's just walking out there staring at the ground for several hours until you find this really minuscule ant. It came down to the thing where I found the easiest way to find these was actually to get on your hands and knees and crawl. That's literally a needle in the haystack sort of thing. I think the real coincidence is that it didn't bore me to death because it's, I don't know, I feel like it takes special personality to be able to sit at a desk and watch ants for several hours when they don't make any sounds and they don't really behave in any way that's intuitive to us. Because these insects or other animals live in societies, they've had to overcome challenges that are analogous to what we face. So they have to build things to live in, right? They have to control their environment. They have to maintain a division of labor. So they have individuals that only perform certain tasks. Then they have to effectively communicate. Obviously, they don't have one ant foreman that's announcing to these ants what tasks to do and what time to do them and how to coordinate things. They're coordinated in a decentralized way. So how has a system evolved that makes their communication system effective? So key differences like that can really inspire sort of changes in the way that we do things. We have sort of top-down control where they have bottom-up effectiveness. So it's really sort of uncovering these behavioral traits of colonies that really keep them cooperative and in check, and sort of the stuff you wouldn't think is happening or even has the capability to happen. It's worth doing because it's just worth understanding how nature works and how natural systems have evolved and how they maintain themselves. And then looking at ants or any social insect like that, it's even closer to us because these are societies that are almost analogous to us in their complexity. These are societies of millions of individuals cooperating and basically living in the same housing structure. So in that sense, questions arise like, how is this possible that all these individuals live together? And how do they maintain their structure and communication and efficient systems? You know, with studying biology and with animal behavior and things like that, a lot of it comes from just a good natural sense of just being out in the environment and observing what's around you. Like, you really don't specifically need a degree to do this stuff. You can be a citizen scientist or like an engineer that also appreciates science or does behavioral studies. It's really just going out there and sort of being interested and curious about how things function and how things interact with other organisms and with their environment. There's tons of things left to be discovered. There's several hundred species of ants in Arizona, for example, and I think we study, out of the 40 or 50 people here that are studying ants, I think we only study maybe 6 species in Arizona at this university. So there's just so much out there that hasn't been studied, that nobody knows how it behaves and what it does and how it's unique from other animals and what adaptations are in the species, that there's just waiting for people to take interest and start exploring.